Let's see today التوبيك اللي احنا هنتكلم عليه. The topic that we want to speak about today هو التوبيك اللي based على اللي احنا اتكلمنا عليه المرة اللي فاتت, which is the solubility. Last time we talked about solubility وعرفنا يعني ايه solubility. قلنا solubility is basically the concentration of the substance that's dissolving. قلنا كمان ايه the
نعم.
relationship between the solubility and equilibrium. وعرفنا ال 3 cases لما يكون equilibrium حاصل او السوليوشن عندي saturated او السوليوشن عندي super saturated. وعرفنا ازاي اقدر احسب ال Ksp لو انا عندي concentration بتاعت السبستنس اللي هي sparingly soluble او السوليبيليتي بتاعتها قليله, او العكس لو اداني السوليبيليتي وطلب مني ال Ksp. وخدنا كذا حاله تعتمد على الريشيو اوف الايونز فورمد. النهارده هنتكلم على التوبيك الاخير في يونت 8 اللي هو التوبيك related للكلام ده, which is the pH and solubility. I will look and see how the solubility is affected by changing the pH of the solution, and then I will see how this is happening exactly. احنا قلنا المرة اللي فاتت ان solubility, and we called it, if you remember, we called it S. We called it S او concentration. ممكن تعتمد كمان على ال pH بتاعت السوليوشن. احنا قلنا مثلا for example if I have magnesium hydroxide MgOH2, we said that it is a very weak solubility substance, so it will break down into Mg2 plus and two ions of the hydroxide ions. And we said that both of them are aqueous, but we will write under the magnesium hydroxide solid to show that it is insoluble. And we said that the solubility is very low, and the proof of that is that the Ksp of this solution is very small. It's almost 1.2 times 10 to the power of negative 10 أو 11 كمان.
نعم.
With very low solubility proven by the very low concentration. And the Ksp of this solution is actually calculated by multiplying the magnesium concentration and the hydroxide ion concentration, but the hydroxide ion concentration should be powered by 2 because it has a coefficient of 2. Now let's see what happens if you change the pH of the solution and how this is going to affect the solubility. Let's say I have added some HCl. So I added HCl solution to my original solution, to the magnesium hydroxide solution. So I know that HCl is an acid, which is a proton donor, so it will give me a huge amount of hydrogen ion, so it will increase the hydrogen ion concentration. For sure, the first thing that the hydrogen ion is going to do is that it will go and react with the hydroxide ion and remove it from the solution, or practically changing it into water molecules. So every H plus is going to react with one OH minus and form a molecule of water. This means that the concentration of OH minus in the solution, which is already low, is gonna decrease. Why? Because it's consumed and changed into water molecules. So the OH minus concentration is gonna decrease. Okay?
نعم.
So لما يكون عندي في السوليوشن ديت ال OH minus decreases, so the solution will try to increase this according to Châtelier, will try to increase whatever has been reduced. According to Châtelier, any ion whose concentration is reduced, the solution will do the opposite. So if you decrease the OH minus, the solution will try to do what? Will try to increase the OH minus. So this means that the reaction is going to move towards the right side in order to compensate the loss that had happened in the OH minus. So there is a loss in the OH minus because it's consumed by the H plus. Every H plus 2 OH minus cancelled it and changed it into water. The OH minus concentration is dropping, decreasing. That's why the OH minus will try to increase to replace what's lost. احنا عارفين in Châtelier, whatever product or reactant decreases, the solution will try, our reaction will try to increase it, and vice versa. So معنى ذلك ان الاس will start to increase. Why it starts to increase؟ لان احنا قلنا المره اللي فاتت anything that moves the reaction towards the right side it moves towards the aqueous ions. So the solubility will actually increase. واي حاجه هتعمل العكس هتخلي الرياكشن تمشي باكورد، يعني تبقى ماشيه ناحيه الاس السوليد، يعني معنى ذلك السوليبيليتي هتقل والبريسبتيشن هيزيد. زي ما بعمل ايه؟ زي ما انا بدل ما اقلل ال H بلس، لو انا زودت ال OH ماينس باي طريقه او زودت ال pH، يبقى انا هنا انا شفت في الاكزامبل بتاعي دوت ان انا لما قللت ال pH بتاعتي السوليبيليتي في الاخر ايه اللي حصل لها؟ اتنكريزد. ازاي قللت ال pH؟ بان انت حطيت H بلس. زي حطيت H plus, you put H plus by adding HCl. HCl has consumed the OH minus, so the solution tries to increase it, so it moves forward. And since it moves forward, the solubility actually is gonna increase. But what happens if you add something like ammonia? I know that ammonia is a weak base, so the aqueous ammonia is gonna react with water as usual and form NH4 plus. We know that ammonia is a weak base, so
Weak base.
it will take the water, exactly, it will take the proton of the water and form NH4 plus, and then the water is going to change into OH minus. This is a conjugate base of the water, because water is an acid here, and this is its conjugate base formed. So this means that I'm going to increase the OH minus concentration, and actually this is the way that NH3 is considered as a base, right? Because it does not contain OH minus, so I cannot define it as a base according to the Arrhenius. Arrhenius only tells me that whatever is a base produces OH minus. This one does not have OH minus, but it indirectly increases the OH minus inside the solution. طيب ايه اللي هيحصل لما تزود ال OH minus؟ مستر اللو شاتليه هتشتغل. What will the Châtelier tell me? You have increased this one, right? So the solution will try to decrease it. So it will move, instead of moving forward, it will move
product side.
back. It will move. عايز تقلل ال OH، فاروح الدايركشن اللي بتعمل ال OH ولا ما بتعملش OH. I'll go to the direction that makes OH ولا does not make it. I want to decrease it because it's increased. So the system tries to decrease.
We go to the side that does not make OH.
Does not make OH, which is the
Reactants.
backward side, which is the reactants side. And reactants, I know that is this the direction of precipitation or the direction of dissolution? Is the direction of precipitation, which means that the solubility actually is gonna decrease. The S or the solubility is gonna decrease when I have increased the pH. So it's not a rule that the pH decrease will cause increase in the S or the pH increase causes the S decrease. It depends on what is your reaction and what are your directions. So again, the conjugate acid, which is the NH4 plus, has caused to remove the OH minus ions. يعني ال NH4 minus، خد بالك ان انا عندي الرياكشن فيه جزئين، زي ما انت زودت ال NH4 بلس عملته وال OH minus عملته، ال NH4 بلس وال OH minus عملته، فزودت ال OH minus، ال NH4 بلس دوت هياخد شويه من ال OH ويرجع يعمل الباكورد رياكشن، صح؟ طبعا بس ما اقدرش اقول ان ال OH minus هيقل. تاني let's focus on this part because this is very important. Two things actually will happen، لان انا مش عندي حاجه واحده، انا عندي حاجتين. انا عندي NH3 بيعمل حاجه وال NH4 plus بيعمل حاجه اللي عكسها، اللي هي ايه؟ And this is not in this reaction. In every acid base the NH3 takes the proton and in the same time the NH4 plus tries to give the proton back in the backward reaction, right? In the backward reaction. But because this is a conjugate acid, which is very conjugate acid, it is very weak conjugate acid, the reaction does not happen backward. It mainly happens forward. Why? Because this is not a strong conjugate acid. It's a very weak conjugate acid. فما بيعرفش يدي البروتون بتاعه. لو كان بيعرف يدي البروتون بتاعه كويس كان بقى ده المين رياكشن. كان الباكورد رياكشن بقى هو المين رياكشن، لكن المين رياكشن هو الفورورد رياكشن. طب كان هيحصل ايه لو الكونجugate acid شغال كويس؟ كان هيعرف ياخد ال OH ماينس ديت ويقللها. لا، هو مش بيعرف يعمل الكلام ده. ليه؟ اللي بيحصل ان ال H2O هو اللي بيدي البروتون بتاعه ل NH3 ويعمل ال OH ماينس. اذا ال OH ماينس at the end decreases, it does not increase. Increases does not decrease. اوكي؟ سو دايما
لما
في
ال NH plus تعطي ال OH minus it's a forward reaction.
يعني let me simplify this in a different way. In every acid-base reaction, there are two people fighting. The HCl is fighting to give its proton to the water, for example. So it gives its proton to the water, right? What will be formed? This is the acid. Its conjugate base will be, which is Cl minus, and H3O plus, which is the base and the conjugate acid. The same way the HCl is trying very badly to add its proton to the water, the reverse reaction is trying to happen. What is that? Is that this acid also is trying to give its proton to the base in the backward reaction, so that it goes backward. But because this is a very weak acid, H3O plus is a very weak acid compared to this one, so who wins? This one wins, and here it wins completely. The H3O, the H3O plus fails completely in going backward because it's a very weak acid compared to this acid. And also, this base is a stronger base than this base, because if this was a strong conjugate base, it would have taken the proton, but it fails in doing that. That's why this reaction mainly goes forward. The same way is happening here, because H3 takes the proton from H2O, so this is a base which is stronger than this base, That's why this base fails to take the proton. What happens if it's able to take the proton? The reaction will go backward, and this is not happening. Usually one direction only is controlling the scenario, right? One direction only is controlling the scenario more than the other. Right? Let's see the solubility equilibrium of barium fluoride, for example. So I have BaF2, and BF2 is a weak electrolyte that will give me Pa2 plus and 2F minus. The Ksp is very weak. It's almost 1 times 10 to the power of negative 6, which is still a very weak number, which means that this is a solid and these two are aqueous solutions. What happens if I lower the pH again? So how do you lower the pH? You lower the pH by adding what? By adding H plus. So what happens? So what happens to the H plus? The H plus will take the F minus ions, and make HF. So this HF plus that I will add will react with this F minus to form HF, which is a weak acid, right? This is a weak acid. So the H plus that I added externally reacts with this F to form HF. So this means that the H plus removes the F minus ions. So what happens when you remove the F minus ions? The solution will try to remove F minus, right? Why? Because it took it, consumed it, and made HF, changed it into HF. So what happens when the solution removes F mass? What is the response for the Châtelier?
It moves backward.
It tries to increase the F minus, so it moves backward. Correct. It moves backward. Mister, when it moves backward, it changes into what? Into more H plus and F minus. So actually, it has increased the solubility of F minus. It increases the solubility. Because now there is more F minus. I produce F minus. Okay. Let's see some questions that comes in exams and see how we can answer such a question in the MCQ if it comes in the exam. So let's see number 1. Okay, so magnesium carbonate has changed into magnesium 2 plus and carbonate 2 minus, right?
Yeah.
The theoretic solution of magnesium carbonate at equilibrium is represented by the equation above. 4 different saturated solutions were prepared and kept at the same temperature. أنا عندي ده الكونسنتريشن 4 different solutions were prepared and kept at the same temperature. A given amount of HCl was added to each solution and data was collected. يبقى كان عندي solution كلهم نفس التركيز، يعني كلهم مغنيسيوم كربونات، بس كل مره بضيف عليهم different number of moles of HCl. وكان عندي هنا 0 added للسوليوشن الاولاني، السوليوشن الثاني حطيت عليه 2.7 4.6. so every time I increase the concentration of HCl or the number of moles that I'm adding. And I'm seeing what's happening to the solubility of magnesium carbonate. What did you notice about the solubility when I increase the H+?
The solubility increases.
So the solubility every time increases when you add more H+, the solubility of magnesium carbonate increases, and he wants to know what is the reason behind that. Which of the following can be, or what is the reason, what can be concluded from the data? The molar solubility of magnesium carbonate decreases with increasing acidity. The molar solubility of magnesium carbonate increases with increasing acidity. The pH or the acidity of the solution has negligible effect on the molar solubility of magnesium carbonate. And from the data, it's not possible to determine the effect of changes in acidity on the molar solubility of magnesium carbonate. So what do you think will be the answer of such a question?
B?
Yes, very good. It's B. The molar solubility of magnesium carbonate increases with increasing solubility. It looks like a very easy question, but only if you understand, then you will feel that it is very easy. But if you didn't study well what is the molar solubility and what's HCl, you don't know actually what's happening in the reaction. Because many of the students ask me, this is a question that comes in the exam. Yes, it comes in the exam like that, but because you understand what is happening, so it looks very easy for you, while a confused student will not understand what's happening at all. So the molar solubility has increased when I increase the concentration of H+, which means I have increased the acidity or lowered the pH. Okay, it only depends on a very basic concept, that knowing that the H+ concentration increase causes to increase the acidity and lower pH. And of course, this is the basis of Unit 8, so we must know it for sure. Let me see it, number 2. So the solution of calcium fluoride is represented by the equilibrium system above at 25. F minus ion is produced لما الweak acid HF dissociates. لو حطيت solid calcium fluoride is added to equal volume of the following solution. يعني أنا كان عندي HF بيعمل H plus و F minus, and I added to it calcium fluoride in equal volumes. In which solution will the most calcium fluoride dissolve? So again, this is my solution. The F minus of is produced when a weak acid dissociates. So this is my basic solution. F minus produced when the weak acid H plus. If calcium fluoride is added to equal volumes of the following solutions. So I'm going to add calcium fluoride to this one, and then add it to this one, and then add it to this one, and then add it to this one. So which solution will have the most solubility of the calcium fluoride? Which one will have the highest dissolution? Which one will have the highest concentration of calcium and fluoride ions? This is the one that I will add Is this the one that I will add the H plus to it? Is this the one that I will add OH minus to it? Or is this the one that I will just keep water? Or if I will add calcium fluoride extra on top of it?
هلا the first one is كأنه H2O plus CaF2 بيعمل H
The pure water plus CaF2.
بصير H3O
So this is my
plus
original solution. I don't expect ان هيكون في change. بالعكس انا محتاج ان انا اقارن دوت. I need to compare this to what happens when I add an acid or a base. So let's take number B straight and see what happens, right? So let's take HNO3. What happens when you add an acid like HNO3? What did we say will happen? HNO3 is going to break down into what?
H plus NO4
NO.
NO4
How do we break the acid? You remove an H and add a
بصير
negative charge, right?
NO2 minus
No, NO3. We remove an H and add a negative. Again, how to form the conjugate base from the acid? Same like HCl. What do? You remove the H and put negative, right?
yes.
To H plus NO3. This is a very basic skill. You must know this very well. H plus and NO3 minus. So this one is a strong acid. It gives very high concentrations of H plus. So what happens when you have high concentration of H plus? What will the H plus do? It will take out
high
what? It will react. It will react with what? Here, this is my solution. The H plus will react with what? Remember what we said here?
with the CA.
What did the H plus react with here? This is my solution. I added H plus. What did the H plus reacted with?
With the F minus.
With the F minus, very well. So it will take the F minus and make HF. So it will reduces the concentration of F minus, right? Again, the H plus produced from the acid, and it's not normal H plus. This is a strong, means very high concentration. So H plus produced from the HNO3 reduces the F minus concentration by consuming it out by reacting with it to form what? HF, right? By reacting with it to form HF. What happens? This is the action. What is the response of Le Châtelier? When the system finds that F minus is decreasing, what will the system try to do?
It will increase the solubility.
It will increase the solubility because when it sees that the F minus is decreasing, the system will try to increase the F minus, right? So it will move in which direction? Backward or forward?
Backward.
Why it moves backward?
Because there's less F minus ions.
And I need to increase or decrease the F minus, I said.
Want to produce more.
More. So I will move in which direction? Which direction forms F minus? Again, look here, look again. You want to make more F minus. So you move to the direction that produces F minus, not that consumes F minus, which is the forward direction. So this means that there will be more F minus. When there is more F minus, does this mean towards solubility or towards precipitation?
Solubility.
Solubility. So this means that this one has increased. This one has increased the solubility. This one has increased the solubility. And this is what we are looking for, because he is asking which one will move this forward more. Okay. What if I put OH minus? What if I put OH minus? Is there anything related? Did we take anything? OH minus is going to react with what? It reacted with the element. I don't have OH minus here for this to react with. I don't have anything for this H minus to react with. If I put OH minus, it's gonna react with the calcium. It's gonna react with the calcium and decrease calcium concentration. So let's see what happens here. لو أنا حطيت OH minus, if I added OH minus, it's gonna react with my calcium, right? To form calcium hydroxide. And calcium hydroxide has very low solubility. يبقى معنى ذلك, this means that it's gonna reduce the calcium. It's gonna reduce the calcium. System will try to move forward. So it will increase its solubility, but not in the same way. Why not in the same way? Because the amount of OH formed, that's not that much. So OH minus is not gonna react with the calcium to form the calcium hydroxide. Right. What happens in pure water? Of course, the pure water is the normal concentration, just the regular one. It's not compared to what happened here. What about saturated calcium fluoride? This is the most important one. What happens in D? Let's say again, I have calcium fluoride. We said I put calcium fluoride on top of my solution. On top of my calcium fluoride, I added more calcium fluoride. When you add more calcium fluoride, it will break to the solution to make calcium and fluoride again, which is already there. So the solution will see that F minus is increasing. So it will try to decrease. So it will move in the direction that's not forming it, which is the backward. So it moves towards solid. It will decrease the solubility. It will decrease the solubility. While in fact, I'm looking forward to do what?
To reduce the F minus.
I'm looking forward to increase. I'm looking forward to increase. So I'm looking for the option that increases the solubility, that makes it dissolve more. So option number A, there is nothing here that will cause the solution to move to the right. I'm looking for anything that causes the solution to move to the right. There is nothing here that will cause the solution to move to the right. So the solubility depends only on the Ksp, the regular one. In number B, it is the correct because H plus produced is gonna consume the F minus. The solution finds that F minus decreased. It will try to increase it, so it will move to the right. When it moves to the right, the solubility decreases because I moved forward. Number C, sodium hydroxide is a strong base. It gives me a high concentration of OH. It gives me a high concentration of OH minus. Yeah, OH minus, as we said, is not gonna react with calcium or with fluoride in a high way that affects the solubility. Type saturated calcium fluoride is not going to be answered because I said when you increase the calcium, the solution actually will try to decrease it, so it will move backward where there is less solid. Okay, if you are confused, it's okay. We can repeat this many times in other questions because this is the most difficult part as I'm explaining. This is the top of AP Chemistry. This is the top confusing part of AP Chemistry. So don't be worried. So let's answer one more. Let's see one more multiple choice. This is number 3. I'm not saying that so you will be afraid, but just to understand that this is a confusing. Just to summarize, in order to make this easier, let me tell you what is going to happen. I'm usually either going to add H plus or OH minus. The H plus is going to react with what? The H plus is going to react always with the conjugate base. So علشان أعمل summary in order to be understood. عشان نعمل summary للquestion, this type of questions. Because I need to answer this fast in the exam. In the MCQ, if you add H plus, it's gonna react with the conjugate base of the solid, right? It's gonna react with the conjugate base. Like last time, when I added the H plus, it reacted with the F minus, and it forms what? It forms HF. So it will decrease the F minus ion concentration. So actually, it will increase the solubility. It will increase the solubility because when you decrease the F minus, solution will try to increase F minus. So it will increase the solubility. If you have OH minus, its effect will come only if there is an OH in the solution. So the effect will happen if you are acting it with a weak base, like here. So in this case, OH minus will do what? If added, only if added to the, I'm trying to write it.
OH minus react with what?
It will react with the calcium hydroxide. So it will react here, it will decrease, it will increase the OH minus. So it's gonna increase the OH minus. So when it increases, the solution try to decrease it, so it will move backward. So it will do what in the solubility? It will decrease the solubility. So it make an opposite effect. I'm trying to write, but it's not writing again. So let me just type it here. So only if there is negative, if there is OH minus in the weak base، مثلا example magnesium hydroxide أو calcium hydroxide OH2، the OH minus addition will increase OH minus. So solution will try to decrease it. So it will decrease the solubility. ليه؟ Because it will move، بتقلل ال OH minus مش بتزودها. Let's see the next one. Just 1 second, please. Okay, the next question: a student investigates the effect of pH on the solubility of silver hydroxide, which dissolves in water. And according to the solution reaction, which is silver hydroxide reacts to form Ag plus OH minus, still a very weak solubility. Ksp is just 2 times 10 to the power of -8. The student places the same mass of silver hydroxide into 50 ml of different solutions with specific pH and measures the concentration. Based on each data, what can be calculated about the solubility of silver hydroxide? What happened here? Can you just tell me without looking at the options? As the pH?
As the pH
increases, the solubility
the solubility will decrease.
will decrease. So this is very similar to what I just said, right? We just said that if there is OH in a weak base like this one, this is OH in the weak base, the addition of OH will do what? Will increase OH. So the solution will try to decrease OH. So it will decrease the solubility. So it's going to decrease the solubility. How this is happening? Let's solubility. وده اللي حصل فعلا. وده اللي حصل فعلا ان انا when I put this like that, the silver I'm putting OH minus, the pH increasing. How is pH increasing? By increasing OH minus. By increasing OH minus. So adding more OH minus solution tries to what? To decrease the OH minus. You are adding OH minus for me, I will decrease it for you. This is the relationship basically, right? I'm doing whatever opposite you are doing. You are increasing OH. How did you know I'm increasing OH? You said I'm increasing pH. pH increase means OH minus is increasing. So it's increasing, solution will try to decrease it. So it moves to the direction that's not forming it, which is the backward direction, which means there is less solubility. That's why solubility decreases. So let's memorize it as a rule. Adding OH minus to a solution by increasing the pH to a solution which already contains OH minus makes the solution, tries to decrease this OH, so it moves away from it. So it causes the solubility to decrease as a basic rule here. Okay, of course, I don't need the explanation in such questions. So if you can see, I already have the data. The data is telling me without explanation, right? The data is already telling me that pH increasing, solubility is decreasing. Only from the numbers you get the answer. So I can choose which one, A or B or C or D.
Uh, D?
Yeah, excellent. It's the perfect answer. Thank you. The silver hydroxide is less soluble. I can see solubility number is decreasing here because higher concentration of OH minus, which means higher pH, shifts the solubility towards the silver hydroxide. So instead of having more of this one, I'm having more of the insoluble substance, which means the solubility is less. Excellent, excellent job. Okay, that's a kind of a question that comes in the MCQ exam, a very easy question. All you need to do is that you know that increasing the pH decreases, increasing OH minus concentration. So basically, actually, this is the explanation. Okay, let's see number 4. I'm getting all these questions from the file of a very famous file found on the internet. I don't remember the guy name right now, but it's very helpful. Okay, so let's see number 4. There is no data here. Yeah, the exothermic dissolution. Let's focus. This is exothermic dissolution of magnesium hydroxide. Means this reaction is exo, the release is heat. Is represented by the equation above. Ksp is 1.8 times 10 to the power of negative 11. Very weak solubility. Which of the following changes will increase the solubility of magnesium hydroxide?
Will increase solubility معناته we have to decrease the pH.
You have to decrease the pH.
يعني إيه؟
Yes, if you decrease pH, let's see what happens. If you decrease pH means you add H plus. So adding H plus removes OH minus, decreases it. The solution says, oh, you want to decrease OH minus? I will increase it for you. So it moves to the right and increases the solubility. Perfect answer. This is exactly again what we said here. H plus reacts with the conjugate base or reacts or with OH minus, decreasing the solubility. So systems tries to do the opposite and increases the solubility. That's a real perfect answer.